I'm having a little problem with the Mazak, and I thought this might make an interesting video to show this issue, and if somebody else is having the same problem, that it might help them out. Now, let me go over to the machine's control and let's kind of look at what's happening here. First of all, I have to close the doors here, which you got to select this and push these buttons. And what I'm going to do is just start the spindle up manually and show you what's happening here as far as the spindle drive. So this might help somebody out. So I'm putting it in a manual mode, and I'm just going to bump the RPM. Well, first I'm going to put it in, I'm going to decouple the C-axis and put it in high range here. This is high range. Okay, now it's in high range. I'm going to increase the RPM up to about 500 and start the spindle. We're getting closer over here so you can kind of see. Right here, I'm increasing the RPM, and you can see it right here. Okay, now I'm going to start the spindle. So see, the spindle's running now. Now the problem I'm having is there's a relay, there's two relays in this machine that switch from a Y connection to a delta connection on the motors. Both the spindle motors do this, but this is the turning spindle here is what I'm having trouble with. But one of the relays is malfunctioning, and I'll show you on the control here how this looks. See, if I keep increasing the RPM at around, I think it's 600-ish RPM, it's gonna change to the other relay. There, it did it. But see, now we've got an overload, almost an overload condition on the thing. And what's happening here, if you watch the RPM, is it tries to speed the spindle up, but it can't do it. And then the spindle falls back down in RPM, and it tries to re-engage the relay over and over again. And oddly enough, this isn't even giving an alarm on the machine. If I back the speed back down to something that's normal for it to stay in the Y configuration, the Y configuration of windings is for the lower speed because it has lower voltage on the motor, but it has more windings in each leg, if you will, because the windings are put in series, and then it shifts to the delta windings, which puts the full voltage on each winding, and so it can go up to the higher speeds with more torque, apparently, is my understanding of that. But anyway, so we'll go around to the back of the machine over there, but I have to walk around because there's no way I can get through next to the wall. And I'll show you the relay and what's happening there. Let's go over here and take a look at the relay. This is the relay in question, or the contactor, if you will. And we're going to walk behind the machine and kind of take a look at this situation here, if you will. I got to walk around this way because I can't get around the chip conveyor next to the wall there. It's very close. So it's dark back here, so I set up a light. So I might kind of mess with the camera here a little bit. And this is what we're looking at here. These relays right here. And in particular, this relay. So what I'm going to do is I'm going to set see, this one is pulled in. You can see it right here. It's pulled in. And this is the relay that's malfunctioning, or the contactor that's malfunctioning somehow. It doesn't look bad, but apparently something's wrong here. And you can kind of see it if I can find a place to, let me see if I can set the camera down here and point it towards these relays. And if I go to start the machine, you'll see it. It'll release this relay, and it's supposed to pull in this one. So let me go start that and duplicate what I just showed you on the control, and you'll see it's released this one, and then it'll pull it back in and release it, because it's supposed to release this relay and engage this one, because this is the delta windings, or the high speed side, and this is the low speed side here. So I'm going back around the machine here. I don't know if this Rode mic will stay connected through the machine. We'll see. I'm going to start the spindle again. Okay, I'm going to bump up the RPM. Now this is about where it changed. And you can see it's disengaged that relay. Now it engaged it, disengaged it. You might be able to see that on the video there. And it'll just sit there and oscillate back and forth because it can't get the high speed connection. I'm going to back the RPM back down. Stop the spindle. Turn the machine off. We're going to hit emergency stop. Power it down. We don't want to be working back there with power on. We got to go back around here. Got me some screwdrivers like I think I'm going to need to do this. Now that the machine's control is powered down, I'm going to, in addition, although this is kind of, I don't know, there's got too much junk back here. Anywhere there's a spare spot in a machine shop gets junk. I'm going to turn the main power off as well. Don't want to electrocute myself. And see if I can get back here without slipping. If I can mount this camera somewhere, maybe I can make a little time lapse or something, or a sped up video of this process. Let's see. It's gonna have to put up with that right now. See if I can, what kind of screws did they put on this? What the hell? Oh, they used some kind of safety torque driver on here. I gotta go find that somewhere. Got this set, and I think this one might work. Let's see. Yeah, this has a this torque drive has one of these little holes in the middle of it. I don't know if you can see that or not. That's the kind of screw they put in there for some reason. Make sure we don't have any power connected on here for some weird reason. Doesn't look like there is. No, we're good. Now, I guess we can power things up here. Let me move these, make sure I don't short out anything out here. Ground bus. Put all my tools down here. Let's go power this thing up and see what happens. While the machine's booting up, I am going to double check this one more time. Let's get over here. Still booting up. Takes a while for this Mazak to start, boot up the control. It's kind of a slow PC actually. Okay, we're good now. Spindle malfunction. Ooh, I don't like that. This alarm, when I changed out this relay, I don't know if you can see that down here, because this contactor on the motor, the coil went bad on this. And when I powered the machine back up, this power supply for this is the turning spindles controller and power supply. It had an alarm and it had a problem. What I didn't understand about this machine is if you leave the main circuit breaker or the incoming circuit breaker power on, it leaves all of this powered up. The only thing it's not actually powered is the servo drives. These, when you release emergency stop, it enables those. But even with the emergency stop depressed and the main switch on but the control off, all of this has power to it still. Those up here, let me show you. It's dark back here, so it's kind of, I gotta have this extra light. But this is the milling spindles power supply and controller, speed controller. The turning spindles, speed controller and power supply. And these are all the servo drives over here. But those relays down here control the winding directions in the motors, the spindle motors, depending on the speed. And this one here, that's right here, that's uncovered at the moment, is the one I had to change out. That has to do with the delta windings of the turning spindle. These particular relays down here, these 4 relays, they remain enabled. Well, actually, the two on this one that I replaced and the one on the end remain on continuously, even though the control is not on, and you know, everything is disabled, but the main power circuit breaker is still turned on coming into the machine. All of this remains powered up, as well as these 2 relays are pulled in continuously. So this is kind of what made the relay go bad, is I had been leaving the main power switch on over there, and it causes this to happen. So I learned my little lesson here not to leave that main power switch on, to turn that off when I turn the control off. I kind of figured when I turned the control off, I didn't know this, that it disabled this stuff, but it doesn't actually disable it for some weird reason. I don't know why Mazak makes their machines this way, but when they have these great big contactors and everything over here that are on the main power, you can't see them from this view. Maybe if which is over here, these, you can see this is the main power coming in through those 2 circuit breakers, but for some reason they leave that on continuously, even though the main power is turned off. I mean, well, not the main power, but even though the control is turned off, but the main power coming in, which is right over here, goes down to a circuit breaker behind that panel. Is if you leave that on, all of this remains enabled all the way up through these relays, and these spindle drives all remain on, even though the control is off. Or even if emergency stop is depressed, but with the main power coming in turned on, this all remains enabled. So I kind of learned my lesson on this one. I should actually turn that main circuit breaker off when I power the, turn the control off. I hadn't been doing that, and that's what caused this relay to go bad. But then when I changed that out and I powered the machine back up, this power supply had a problem with it, an alarm. And I had the guy out from, well, the guy I have work on my machines, he's not a Mazak guy, he's a different guy. He checked this all out for me, and he didn't even charge me for doing it even. And he said, I got to replace this power supply, unfortunately, which right over here, I got the new one sitting there ready to go in when I take this one out. And unfortunately, that thing cost about $11,200. They'll give me a 25% credit back if I send the old one, which is going to be this one, back. Kind of like a core charge if you buy car parts, I guess, similar to that. So I'm going to take this out here, and we're going to see how I'm going to go about doing that. Just take this top off this thing, this power supply, and see what's in here. What are we getting for our $11,000 here? It looks like there's some kind of circuit board right here, but I don't know if I'm blocking the light kind of right here. Let's see if I can. Fortunately, I can't really, I can't put the light in a better position here. I don't know what to. See what this looks like in here. Can't really tell. There's stuff behind this back of this thing in here that I don't know what's back behind there, but these kind of big bus bars. There, it looks like there's a. I mean, I'm no electronics expert, but I think there's three big like rectifier things or something in here. It looks like it. I've got these little circuit board. Some big capacitors underneath here. You can't see them, but there's like three. I don't know, 2 or 3 big capacitors right there. And these big bus bars are going down to these devices down here. There's 3 of them. That must be the rectifier thing. I don't know what these are. These look like a. Can't tell. They're covered with shrink stuff. They got small wires running to them. I don't know. There's some kind of a. Well, I'm not sure. I'm not that much of an electronics expert, but these big buses are coming up to the where the power comes out of this thing, over here to the spindle drive and over here to these servo drives. So those must be controlling the power somehow or another. Little controller circuit board here, and I mean, I don't know. There's a circuit board underneath this one. Can't see it very well, but a lot of money for just that little bit, it seems like, doesn't it? There's on the back side of this thing, when I pull it out here, there's a big heat sink that these three deals are connected to, I believe. It's whatever those things are. They go all the way. Looks like they go all the way up to the, almost, it continues on here, so they must go all the way up there. Maybe that's the, ooh, see, that thing's heavy. See how nasty those fans are? Wow, it's pretty heavy. Yeah, see, the air flows through here inside this box here. This is the back of that transformer that I was talking about earlier right here. I don't know if you can see that or not. Kind of where these cutouts are in the panel, and air kind of flows through here in the machine. Keep things cool, kind of, but it's like covered with you see the oil dripping off of here. You can see it kind of, I don't know if you can see up here, you can see it kind of running down. Everything in the shop has got this oily mist in the air. Now, it's kind of tight here. I have to move this around. Gotta close this door so I can get by. Right now, I'm just gonna set this thing here. I have to put some of those screws and stuff back into it, because I got to return that thing to Mazak. This one, I'm kind of up against the wall here, so it's kind of tight, like I said before. Let's see what we've got here. I don't know if you can see what I'm doing here. Let's see. Just taking the front panel off of this one so I can kind of this, some additional bus bars that I guess replace the ones that were up here. And this switch right here has to be set to the right number. It's a little rotary switch thing. It goes from 0 to 10 or 9, and then A, B, C, A to F. And for this particular thing, the guy told me to set it on 0, which is the way the other one was set. So this is a brand new power supply, they told me. It's not refurbished or anything like that. Forgot these, didn't I? And this one here. I don't think it would have worked without those hooked up. All right. Getting close to when we can kind of let the smoke out. See, when that power supply was bad, there's something in there, senses something that pulls this relay in over here. And that relay wasn't pulling in. And so when the spindle drive and everything powered up, you know, it would get a, because this is where the power comes through and comes up to here from this contactor here. But there's something in here that senses whatever this power supply is doing to pull that contactor closed when the servo power comes on, I guess you might say, or when the whatever power comes on. Or maybe it closes immediately when you turn the main power on. Like I said, all of this is powered up even though the control is off, but if you have the main power circuit breaker over here on the outside of the machine, if you leave that on, then all of this area is powered up in this cabinet continuously. This is what I didn't realize this, because I was just leaving the main disconnect turned on, but turning the control off. And I don't know if that had any bearing on this thing failing sooner than it should, but I kind of learned my lesson on that one. And the guy that came to work on the machine said, yeah, you should really probably turn that main circuit breaker off every time you power the machine down. It would be better, because it would take the power off of these things inside here. And so that's what I'm going to start doing. I don't know if that'll make this. On my Mitsubishi horizontal, I've always done that. I've always turned the main disconnect off every time I turn the control off on the machine. But I hadn't been doing that on this Mazak. And it's probably because I'm lazy, because I have to walk around all the way around the back of the machine over to here. The circuit breaker is like right on the outside of the machine there. And that's probably has to do with being lazy, I guess, than anything else. So we're getting pretty close to doing the initial smoke test here, and hopefully it won't be a $11,000 smoke test, so to speak. So here we go. Gotta reach over here. The switch is outside here. I'm gonna turn it on. And hopefully I hooked everything up correctly. I made sure that little switch is set on 0 like the other one had. So far the LED indicators look good on these things. Pulled in these two relays. This one must get pulled in when I release emergency stop. So everything looks good here so far. Let me go around and turn the control on. So far so good. The control has to boot up before the servo power pulls in. I've released emergency stop back there already on the control, and all these drives are so far reading the same LED reading, which is good. This came up with a 76 on it, which was the alarm 76 before. I don't know why, but that PC takes quite a while to boot up on that control. It's a kind of a PC-based control on this machine. And when it boots up, it'll turn the servo power on. I'll just watch it here and see what happens. So far, everything looks all right. No smoke coming out of anything. There we go. Now pull that relay in. Awesome. It's perfect. See, it pulls this relay in when the servo power comes on, and all of these are doing good now. And before we had this 79, alarm 79, an error code and a, I don't know, it was an A or something on there, on this LED, and it's all showing good now. So hopefully, let's go around. Let me undo the camera here. Let's go around to the other side. Kind of tight here. Let's see, they got the high pressure coolant pump here. Got to walk over the top of it. There's a wall right here real close to this machine. Just go around here and see what we got going. I don't see any red light on the machine's control, so that's good. No alarm. Awesome. I think we're doing good here. Let me I'm going to open the doors. I left the doors closed, and then I couldn't open them because of the alarm. And then we're going to zero return the machine, and we'll see. Then we'll have to close the doors again and see if we can start the spindles and run them through their range. Okay. Zero the B axis first. Move this up. We're going to zero the X, Y, and the Z. Here. And then I usually couple the C axis after all that happens. And technically that isn't absolutely necessary, but I do that just in event. Because sometimes the machine, you'll start the program, but it won't run because you hadn't zeroed that C axis. Although technically that shouldn't be necessary, but I found that to be the case. So let me close the doors. Let's see if we can run the turning spindle through its range. So everything should be fine. That when this thing would run in low range or any one of the ranges, it would go up to about 500 RPM I have to disconnect the C axis, and I'm going to put it in high gear, because this is, I can tell in either one, and I had it at about 600-ish RPM or so. So I'm going to run it. I'm going to start it at 500 RPM right now. So that looks good. And at 600, around 600 RPM, it would change windings on the motor. I don't know if you got a bad reflection here. Maybe if I get closer, that'll go away. And it would oscillate. It would switch the windings, and it would try to speed up, but it couldn't, and the motor would not just be coasting down, and then it would hit the low speed, and it would pull that contactor back in for the star or Y windings, and it would start back up and it'd speed back up, and then it would hit the change on the relays, and it would keep just oscillating back and forth, no alarm. So let's see what happens. So here's 600 RPM. So right a little bit higher than this is where it'll change those windings. There, I don't know if you could hear it click. So everything's working now. See, so I should be able to go up to 1600 RPM is the maximum, which is there. So everything seems to be so it'll only go 490 RPM in low range. So let's stop it, and I'll shift it to low range and start. So that's our 460 RPM is the maximum. It'll go in low range, and let's see, let's go all the way down to, well, it'll actually stop in low range. That's 10 RPM. That's the minimum RPM apparently in the manual mode. And we'll go up. That's 100 RPM, 200, 300, 400, and 60. That's the maximum RPM in low range. So let's see if we can reverse the spindle. It seems to be working fine. So I think everything's working now. Thank goodness. So I don't know if I continue from now on to turn that main circuit breaker input power switch off, if that would increase the life of these electronic components or not. I'm going to start doing that and see, but I may not even own the machine long enough to tell if that helped or not, but we'll see. So repair done for right now. I just got to clean up my mess in the back, close those doors, we're ready to go.